Hi, I want to talk about the discussion board conversation that we've been having with regards to the supplemental handout, question number 7. So we've been going back and forth, and I thought it might be easier just to make a video to talk about it. So just to remind us, what's the question? So let me go ahead and have it written down here so maybe you can read it. So from a group of 7 men and 7 women, 5 people are selected to form a committee so that at least 3 men are on the committee. In how many ways can this be done? Okay, so one of the questions that came up was why is it in this solution we need to consider choosing men differently from choosing women? Why don't we just combine the men and women and choose 3 from there? And the problem with that is that we have to choose 3 men, at least 3 men. So why do we separate men and women in our answer? Because it says in the question that at least 3 of them have to be men. So it's unlike a lottery system where like you have like a million people play and you choose 10 winners or something like that. Of course, in that situation, you wouldn't be separating men and women because you don't reward lotteries to a specific number of men and a specific number of women. If you did, you would need to separate them out before you did your selection, right? So let me go ahead and go to the piece of paper and let's work through this problem together and see how we get to the answer, okay? So, all right. So we have the group of 7 men. So I'm going to go ahead and draw a circle representing that these are the 7 men. We have a group of the 6 women. Okay. From these 2 groups, so it is a total group of 13 people, right? So from these groups, we are going to choose, from the group of the 13 people, we are going to choose, we're going to choose 5 people, right? But this 5 people must be composed of at least 3 men. So at least 3 men. Plus possibly women, right? I mean, we could have all men. So plus maybe some women. Though it need not have any women, right? Because at least 3 men, it could be that 5 men are selected, right? We're only choosing 5 people. Okay, so the most straightforward way to do this is to think about what it means to have at least 3 men. So at least 3 men means that you could choose exactly 3 men. Okay, all those, say there's, certain number of ways that this can happen. We would want to add that, however many ways, this could happen. We would want to add that to the number of ways that we could choose exactly 4 men. Right? That is choosing exactly 4 men is still choosing at least 3, right? And then we would add that to the number of ways that we are going to choose exactly 5 men. All right? So this would be the number of ways you can get at least 3 would be the sum of these. All right? So number of ways that we can get exactly 3 men. Well, you have 7 men. So we're going to choose 3 from those 7, okay? So we can't choose these 3 from the 13 because these 13 are mixed of men and women. We have to choose 3 men to be part of this count. Okay, so its order doesn't matter, right? We don't care if we choose Jacob, John, or Max as our 3 men, or Max, John, and Jacob, right? We don't care about the order of these men. Since order does not matter, we are choosing combinations, okay? So this is not a permutation, but a combination, because these two things are the same. All right? So, okay, so I chose my 3 men, but I'm choosing a total of 5 people, right? And so remember if I have a total of 5 people and I've chosen my 3 men, I can't choose any additional man, right? So I must choose a woman. So I'm going to choose 2 women if I chose 3 men. Now, why am I multiplying these by each other? These counts by each other. Well, this is the basic counting principle, right? That if there are m number of ways one thing can happen and n number of ways another thing can happen, the total number of ways that the 2 events can happen is m times n, okay? So that's why this is the basic counting principle. That's why we are multiplying these. All right, so we're going to add that to the number of ways you can choose exactly 4 men. So 4 men, 7 choose 4. And we would multiply, if we have 4 men, then we only have 1 woman. All right, because that adds up to 5. Now choose exactly 5 men, 7 choose 5. Now you don't choose any women, so I can leave this blank. Actually, if I write down here 6 choose 0, 6 choose 0 is 1, okay? Because remember, 0 factorial is 1. 0 factorial is 1. So if you plug this in, you should get 1 here, so it doesn't matter if you write it there or not. Okay, so if you add up all these, this comes out to 35 times 15 plus 35 times 6 plus 21 times 1, which is 756. Okay, and this is just a matter of using the combination formula and choose k equals n factorial, k factorial, n minus k factorial. Okay, all right. Though it was mentioned, and so I want to talk about in the discussion board, it was mentioned, could we use, so we have our 13 people, the total number of committees there are, how many total committees are there? So if we have 13 people, right, we have these 7 men and 6 women that make the 13 people. The total number of committees is 13 choose 5, right? Could we use that to get to our answer, right? So 13 choose 5 is 1287, okay? 1,287. So there's 1,287 total different committees that are possible. Could we use this to get to this answer? Yes. We could go around this problem slightly differently. So let's talk about how could you go around this problem slightly differently. If this it's not that intuitive to you, maybe somehow thinking about the total number of committees that there are might help think about this a little more. Okay, so there are 1,287 total committees. But not all these committees have at least 3 men, right? So this is the total number of possible committees. Not all of them have at least 3 men. So how many of them don't have 3 men, at least 3 men? Well, so let's think about the number of ways to not have at least 3 men. So the number of ways to not have at least 3 men. Well, if you don't have 3 men, then maybe, so you're choosing exactly 0 men. Or you could have choose exactly 1 man, or you could have chosen exactly exactly 2 men, right? 0 men, 1 man, or 2 men, then you would not have at least 3 men, right? So let's think about this. Exactly 0 men. Exactly 0 men. So that'd be 7, choose 0, right? That's basically 1. It's basically you chose all 5 of them to be women, so 6 choose 5. Exactly 1 man. So 7 choose 1, 6 choose 4. Exactly 2 men. 6 choose, so you got your 2 men, so you'd have to have 3 women because you need 5 on the committee. Alright, so let's see, this comes out to be 6 plus 105 plus 420. Alright, which adds up to be 519. So, if you take the total number of committees and subtract off the number of ways to not have at least 3 men, then you would get the number of committees that do have at least 3 men, right? So this is the number of committees with at least 3 men, right? So this is the total number minus number without 3 men, at least 3 men. Okay? Right? So, yeah, so let me just draw a little diagram maybe to help visualize this. So, we have, the total number of committees and some of them have at least 3 men and some of them don't. So either you do or you don't. So these ones do have at least 3 men and these ones don't. So if you take the total and you subtract off the don't, then you get the do, right? So I hope this helps this topic. Please let me know if you have any additional questions so I can try to clarify it a little further.